Good afternoon. I'm here to present my seminar topic, that is preparation of functional and eco-friendly textiles using inkjet printing. First, I will go with the first slide. That's the contents which I have shown in this PPT. Then next slide will be my introduction. I was born in the year 1986 in the small town of Indian occupied Kashmir. Then later on in the year 2008, I undergraduated from University of Kashmir. In the undergraduate, chemistry was one of my subject. Later on in the year 2010, I done masters in the organic chemistry from Barkatullah University, Bhopal, India. And then I joined for my MPhil program in chemistry also. And in the year 2012, and then in the year 2013, I got enrolled in my PhD program in the Jamia Millia Islamia University, New Delhi, where I worked on dyeing of wool with natural dyes. Here I worked with Professor Muhammad, and I have published number of papers here. So I worked basically on wool fiber with natural dyes. And later on, I moved out of India, and in the year 2019, I joined the group of Professor Fang, where I worked on the topic of inkjet printing, preparation of functional materials and eco-friendly textiles by inkjet printing. There,
Participantes online.
my contract
I
2 years, and later on, I moved here. Now, this was my main why I have been involving in inkjet printing. The main theme of my research is that to print eco-friendly textiles to eliminate the problems of petroleum, it is synthetic dyes. They generally, when we synthesize synthetic dyes, we use synthetic colorants, and that are very harmful to us. Like you have seen about azo dyes, they are carcinogenic to us. So in eliminating these synthetic dyes, I have chosen natural dyes in inkjet printing, which is very new. Only a few papers are in the literature about use of natural dyes in inkjet printing to make hygienic baby clothes. These were some instruments which I have been used there. This is inkjet printing machine. As clearly you show that this machine, there is print head where the ink drops on the textile fiber, and there is formation of print on the textile fiber. And second, I use light sizer. By light sizer, I characterized ink in terms of particle size, because particle size has very essential importance in inkjet printing. Uh, if we have a larger size, like if we have above 100 nanometer size, it will cause print head to block. So we will not get the print quality very good. That's why I used light sizer here. Then I use also turboscan tower, which is very important instrument for ink formulation, uh, because I have to check the particle size as well as the stability of the inks, how much it will be stable. If I formulate the ink, then how much time it will be stable. What what will be the parameters to deal with this stability? I checked by this turboscan tower. Then why I choose inkjet printing for my research purpose? It's because, as you have seen, that there are number of advantages over conventional printing that first it has quick response to fashion trends. It means that if in a market there is a fashion trend which is latest, we can design the fashion trend in our inkjet printing machine and make and make them in our lab, and there is excellent resolution. There is very good pattern quality. Also we can eliminate the problems which were used in conventional printing, like excess amount of solids, excess amount of water, excess amount of salts, and easy little by inkjet printing it's we get little pollution. Then also the essential criteria is the application of inkjet printing. It has many wide applications, like I have few shown here, like flexible electronics, textile printing, uh, biotechnology, solar cell. These are some applications. Then these are the steps which I have been used when performing my experiment. These were the experiment protocol. What I have done, this overall summary here, that first I used to preparation of my textile fibers. I had to use which kind of fiber I need, what will be its characteristics, so that it will be feasible for inkjet printing. These are shown as that there are pre-treatment processes. We have to check zeta potential, also morphology. Then second step was the ink formulations. This is the another important characteristic parameter for the inkjet printing. We have to prepare such kind of inks which have a good solubility, which have a good stability and the surface tension and rheology, that is viscosity, and also the particle size to load in order to load them in the inkjet printing, because these are the essential parameters which are good for the aesthetics of the print quality. If we have a desired surface tension and rheology, we can we can get very good inkjet printers. Then coming to the third step, that loading inks to inkjet printing, this is another very important step. Through this step, we have to study the morphology of the ink drops. It should be very circular and good by taking videos and photos. And then finally, after printing, the fabric is characterized by different characterization methods, like sim, how much the ink printed in fiber, that is calculated by the formula, and also by the microscopic images. Then also some characterizations like fastness, color properties, and infrared spectra. This was my overall research step. That is, first step is pre-treatment. I have treated cotton with some chemicals so that it will feasible for the inkjet printing. Then second step was my rheology, to understand the behavior of the inks which I have formulated. Like I have to check the particle size, I have to check the solubility, I have to check the surface tension, viscosity, zeta potential, all these before loading them to the inkjet printing. And then in the inkjet printing, I had to check the droplet morphology by taking videos and photos. And then finally, after printing, I had to make sure about are the prints are very good. And then I will characterize by them through different spectroscopic techniques, and as well as fastness and colorimetric techniques, and also biological properties. This was the chemical which I have used for my dye. That is, it's known as 3-chloro 2-hydroxy profile trimethyl ammonium chloride. This is known as Chaptec, and which is easily available at Dow Chemical. I have used different concentrations of this chemical in order to modify the cotton. So why I choose this chemical? The reason behind is that cotton occupies negative charges with the water. When we wash cotton clothes, it gets negative charges on them. That is why my dye is anionic dye, because of it contains carboxylic groups. So it will ionize in the water, That's why there will be the cotton has negative dye and the negative ends, and the dye, my dye has negative angles, so there will be repulsion. That is why I modify cotton by cationic substance, cationic chemical, that is chaptec, to make it cationic, and then there will be the strong bonding between the anionic dye and the cationic cotton. This is the synthesis of chaptec. These are in the acidic medium. There is a reaction between the 2,3 epoxy propyl chloride and trimethyl ammonium chloride, and we get chaptec. But the chaptec itself is not directly reacting with the cotton. In order to react with the cotton, we had to uh, make first uptake, which is which is when we chaptake, when we react chaptake in, when we put it in the alkaline conditions, we get uptake. And this is the reaction between the cellulose and the uptake material. Unit cellulose contains OH groups, and at OH group, it will react with the uptake, and it will get the this is the reaction between this uptake and the cotton. This was another step is ink formulation. This was the ink which I have been used for my experiment. The color index of this ink is 75470. This is called as carmine, which is extract from the female insects of Declopus coccus. Commonly, it's known as cochineal insects, but we get from the female insects which grow on the plant Opuntia. It's because the reason behind is that the female insects are immobile. They secrete a white secretion on their body in order to get protected from the environment. That is why they secrete this and gets they when we crush them we get this red carmine dye. But male cannot secrete that uh, fluid. That's why they are moving from one station to another. That's why only female insects are crushed and we get that carmine dye. This is the color of the carmine dye in water, and this is the structure of the carmine dye. This is was reported by some scientists, and this is the molecular modeling of carmine dye. You know that the aluminum is like a chelating agent between the two anthracene moieties of carmine dye. One is above and one is below. Now, first part of my experiment was the effect of pH, time, and temperature on aqueous solution of carmine. The pH has very important effect on carmine dye. As you can see that as we move towards the acidic conditions, the carmine dye precipitates. And if we consider time, there is no change in that. There is slightly change in the color of the dye, but there is no precipitation by increasing time as well as temperature. Only the pH have a valid effect on the color as well as the morphology of the dye, because in the acidic conditions it get precipitated out. Then why this happens? It gets precipitated at the acidic conditions? There is aggregation of dye, so in the acidic conditions, we cannot use this dye for inkjet printing because we have a good particle size. We have 100. We should have 100 nanometer below size of the particles. So in order to get used in inkjet printing. So here we came to know that the optimum pH of carmine dye should be 8 to 9. In order to confirm these results, I have chosen another experiment that's called as light scattering experiment, which I have shown in the experimental slide. That is, the instrument is called as Turbiscan. It's whole based on the light scattering experiment. I have done that experiment by taking the different pH of carmine dye solution. Here you can see that there is width of the back scattering curves. it means that there is aggregation of dye when pH was 6.19. It means that at this pH, the dye is not suitable for inkjet printing. Now, I go to upward conditions 6.6. Again, you see that there is dye aggregation. The back scattering curves are, there is width of the back scattering curves. It means that there is again dye aggregation. When we move towards alkaline conditions, there is again diflocculation or dye aggregation of 1% carmine dye, and then I again move to 7.9 to near to 8. Here you can see there is less dye aggregation, there is less diflocculation. It means that the width of the back scattering curve is here is less. It means that the here dye aggregation and diaggregation does not happen. That's why in this area we can choose this dye, we can choose this pH for inkjet printing. If we move further away, there is again the length, the width of the back scattering curves is less. It means that there is no diflocculation. If we move towards again further alkaline conditions, there is again diflocculation. It means that at 8 point more than 8, the dye particles are in good side. But if we move towards above more than more like 9, the dye again deteriorate. It means that the dye particles are again increasing. This was the total stability index curves. Here you can see that the sample 5 and the sample 6 means at this range of pH 8.40 and 9, this dye was stable, and this dye has a very good particle size. So these are the conclusions. I have told you that if we move to the acidic conditions, there is increase in the H positive ions which react with the water, and they make H3O positive ions, and there will be the scarcity of water, so the dye precipitates. And if we move towards the alkaline conditions, more alkaline conditions, more than 9, it means that there is a larger number of OH negative ions, and there will be the repulsion, and again this dye size of the particles goes on increasing. And if we put slightly, if we put in the range 8 to 9, there is ionization of the carmine dye. The carboxylic group gets ionized, and that's why in this case, in that area of pH, we have a good particle size. This is again the explanation why it happens, because the DLO theory and explains this phenomena, why this happens. It explains the stability of the colloidal particles in solutions. Why this happens? Because that if we move acidic conditions, there occurs van der Waals forces, and if we move alkaline conditions, there occurs double layer forces. If we move in the van der Waals forces increased if we move acidic conditions, and in the alkaline conditions we get double layer force increased. I have shown again this is happening with the when dye particles are approaching to each other. This phenomena will happen. This is the electric double layer which I have shown. Is also called as Helmholtz layer. The stability of the colloidal particles depends upon the width of this Helmholtz layer, electric double layer. Here I have shown when the dye approaches each other in the acidic conditions, what will happen? There will be the increase in the van der Waals forces, so the dye aggregates. But when there will be the repulsion, that is there is the increase in the double layer forces, there will get the decrease in the Helmholtz layer, and it means that the dye will not aggregate. Now this is the another experiment. I have used solvent here to make more precise particle size for the dye molecule. Here I choose ethylene glycol for, for solvent to check the solubility of carbon dye. I use UV visible spectra for this to understand what happened to dye, what is the interaction between the EG and the dye molecule. Here you can see from the UV spectra that if we if we see the black line 1% pure dye, the absorbance is low, means it's not stable. When we increase the concentration of the EG, the absorbance gets increased until 30%. But if we again increase to 40%, the absorbance gets down. This is because that if we make the concentration of 40% high, so all the water will be absorbed by there will be the interaction between the water and the EG molecules. So more water will be needed to dissolve EG molecules. So that's why the absorbance gets down. So the stability decreases after increasing 30%, above 30% concentration of EG. Why it happened, why the absorbance increases and the dye solubilize? The reason behind this is that the EG contains hydrophobic parts and the hydrophilic parts. Although when I choose dye in the water molecule, there is hydrophilic interaction between the water and the hydrophilic parts of the dye. But in the EG molecule, there will be the hydrophilic interaction of the water and of EG molecule with the dye, as well as there will be the hydrophobic interactions of the EG molecule CH2CH2 group and the hydrophobic ends of the dye molecule, that is carbon anthracene, two anthracene rings that are hydrophobic. I have shown that there is hydrophobic interactions between these dye molecules. That is why it gets stabilized, the particle size gets reduced. This is another experiment which I have shown with the EG molecule, that at what pH it should be stable, at what pH the absorbance should be. Again, from this result, it confirms that within this range, 7 to 8 or 9, this range have a good absorbance. It means that this range, this dye is suitable for inkjet printing. So this is the conclusion. Now again, I make another experiment, the effect of dye concentration. What will happen to the particle size of the dye if I increase the concentration of the dye? So here I choose first day I measure the pH, and then second day I measure again the pH, and there was slight difference in the absorbance, means this dye was stable after 24 hours. This was the particle size distribution. Within this range, that is 100, this range, the particle size is very good, both of at 0.1% and 1%, both have a good distribution of the particle size, both have a good hydrodynamic diameter. It means that both are feasible for the inkjet printing. To confirm these results, I check Turbiscan tower experiment again. You can see from both the curves that there is more width of backscattering curves in case of 1% dye, and there is less width of the backscattering curves in case of 0.1% dye. It means that when we increase the concentration of the dye, it means that the dye particle, there is increase in the size of the particles. So it means that at low concentration of carbon dye, this is feasible for the inkjet printing. Again, we check the total stability inkjet total stability index curves. Here we can see that 0.1% dye is more stable than 1% dye. This is another two parameters. These are another parameters, that is surface tension and the viscosity. These are also important parameters. Here we can see that water has its own surface tension, but dye has slightly less surface tension. It's because of the behavior of dye molecules in the water. And then when I choose EG molecules, the surface tension gets down. And this is because surface, the hydrophilic and hydrophobic interactions of the EG molecules and the behavior, how they behave in water. The hydrophobic ends gets outside, remain at interface, and the hydrophilic ends remain in the water. That is why this happens. Again, when we talk about the viscosity, viscosity is another essential parameter for inkjet printing. Again, you see that with EG molecules, the viscosity gets down. The reason behind this, there will be the strong interactions between the EG and the dye molecules, and because of that, the more bonding will occur between these two, and it will become more viscous. That's why so viscosity gets down. Then again, I calculate the hydrodynamic dynameter. All of the three, I also tried with the DMSO. All of the three solvents as well as the 0.1% carbon dye all have good absorbance as well as good particle size. Here I checked the surface tension with DMSO. Both have good surface tension. Here is the behavior of DMSO in water, that the hydrophobic ends remain at the interface and the hydrophilic ends remain towards water. That's why the surface tension gets decreased. Then this was the final ink formulations with solvents as well as with dye molecule. These I have explained. This was the final preparation of the ink. I use 0.1% carbon sample for my experiment. These were the droplet images. When I load carmine dye to inkjet printing, first I check the droplet morphology. If it is in circular, it means that it has a good print quality. If it's like in the dumbbell shape or cone shape or other shape, so it's not feasible for the inkjet printing. For inkjet printing, it should be in the circular shape and it should have a less surface area size. So we will get the good print quality. So here you can see that it has a very good droplet images. Then these were the inkjet printing images. First were with the untreated, second with the 25 gram per liter concentration of chaptek, and third with the 75 grams per liter of chaptek. Here you can see with the treated cotton, we get higher color strength as compared to untreated cotton. Here is the video which I have taken there. This is inkjet printing. Then why this happen? What is the mechanism behind this? Why there is increase in the color strength values? These are the data. The reason behind this that I have already discussed, that cationic agent will react with the cellulose, and there will be cationic sites on the cellulose chain, and after that they will interact. This is the reaction between the carbon dye, chaptek, and cellulose. After that, I have shown this mechanism. After that, they will interact with the anionic part of the carbon dye. This is the color in untreated cotton is because there is hydrogen bonding. Due to that, there is color in the untreated. This is the mechanism which shows the interaction between the carbon dye, chaptek, and cellulose. You can see from the mechanism that there is the strong ionic bonding between the cationic cotton and the anionic dye molecules. These are we get magenta color from carmine dye. This is the color diagram from below red, in between the minus B and red and plus A, there is magenta color. This is the imprintation formula. So you can see that the untreated cotton have a very high in penetration factor, it means that the ink goes inside the fiber. But when we see that treated cotton, we see that the ink penetration is not as much as then untreated cotton. It is because the ink is on the surface of the cotton fiber. These were the Leica microscopic images, the behavior of dye when it falls on the cotton fibers. These are the all are final conclusions that I have got higher color strength on the cotton fibers by cationic modification of the cotton, and these are the next plans. I will continue my experiment with EG and DMSO solvents, and then we'll characterize them, and then I will get the eco-friendly inks for inkjet printing. Thank you.